Okay, welcome everyone. Let's get started. Do these two gentlemen got a seat? So, welcome to the session about giving your Xamarin apps eyes, ears, and a brain with with cognitive services. Just a quick raise: who of you are mobile developers? Oh, a lot of them. And who already did something with cognitive services? Well, only a few of it. That's quite good because, well, this session is all about an introduction to cognitive services and how you can use them in your mobile apps. First, a small introduction of who this guy is that's doing this session. My name is Geert van Cruijsen. I work for Spirit, and I work there as I call it myself, a mobile-first, cloud-first architect. I help companies build better applications, both on mobile as in the cloud. I also run the mobile developers meetup together with Roy and some other guys. So I've seen some familiar faces already. But enough about me. Let's just get started with the content. And the content is about cognitive services and AI. And I guess most of you visited the keynote session this morning. It was all about AI. AI is the big new thing, right? Everyone should be doing AI stuff because, well, it's hip, right? If you look at the hype cycle, it's not for you to read all the things, but all those AI things are really up in the hype cycle. So it's really things that are really hyped right now. So how can we join this hype? First, a little bit of background story about AI. AI itself is nothing new, right? There was AI since several years back. So if you look back in the 1950s, we had Alan Turing inventing the Turing test. So a test to see if someone who you were talking to was actually a machine or an actual human, right? So back then they were already thinking about AI and how can we see AI versus actual humans. And we still use this Turing test. Often we use it in reverse. For example, Captcha tests. They are actual reverse Turing tests where we actually want to check if a machine is a human or if someone is a human and not a machine. And if we really look back at the history of AI, Marvin Minsky, also back in the 50s, he is seen as really the father of AI. He came up with all the concepts that we currently use in AI and the things that cognitive services also are built upon. He started this project, the Dartmouth research project in 1955, and he came up with several topics that define what AI is. He came up with 5 different topics, and for example, knowledge representation. AI should be able to store knowledge and learn itself. It should be able to do perception. It should be able to see. It should be able to process language, right? And the keynote was all about language. It should be able to do planning, navigation, stuff like that. And it should be able to reason, think, make decisions. And all these different topics together, they can turn into a generalized intelligence, a intelligence that could mimic human intelligence. Are we there yet? Are we at a general intelligence level? Well, we're far from that. But in these 5 subcategories, we're making real progress. And if we're going to look at cognitive services later, we can really see that there are several APIs out there that do a really good job in those specific tasks. But combining them all together is something that's still far away for us. So general intelligence is still far away, right? Even these simple tasks like automated driving, Tesla is doing a great job with it, but it's not on a human level yet. And maybe it's a good thing that well, general intelligence is not there yet, right? We all visited the keynote. We saw what the future could bring us. So this is another scenario that could that a general AI could bring us. So why AI now? Right? It's been there from the 50s. Why should we start doing AI now? And that's because of machine learning getting a lot of traction. Our machines are getting really fast, and machine learning has just became available for everyone to use since a couple of years. And if you see that, for example, Microsoft is building their models and training them, you can really see that they're making really good progress compared to actual humans. For example, in this image recognition sample, we see that a few years back they were at a 20% error rate, while now Microsoft AIs are able to do an error rate of almost 7%. Same for speech recognition, 26% error rate a few years back, but now it's 4%. And 4% is still 4%, but the human level is actually around 5 or 6%. So at speech recognition, computers are actually better than humans. But humans still have the general intelligence to combine all those things. So let's do a small test with all of you to see if you can beat computers. So on the next slide, I'm going to show you a picture with several dogs, and you have about 2 seconds to count them. And well, let's see how that works. So how many did you guys see? Who came up to more than 5? More than 7? 10? With more than 10? But there were only 10. So if we look at these pictures and how we can recognize them, before, in a few years back, when we would build AI machines, then we would make all kinds of rules on how to see what an actual dog is. So we would implement all kinds of rules to recognize a dog, right? So we have some rules to look for ears and eyes, and the eyes are always between the ears and the mouth is beneath the eyes, stuff like that. With machine learning, we just feed a large amount of images, so several thousand images of dogs, and we just give that to the machine to learn from that. So they will build their own neural network and make their own decisions on what is a dog and what is not a dog. We as a creator of these neural networks, we don't care about how this machine makes these decisions. We just feed them the data, tell what data is correct and when he was not correct, so he can learn and improve itself. That's what machine learning is all about. Okay, so we have AI. That sounds like something we want to do. So why AI together with mobile, right? Most of you were mobile developers, so why should we join the hype as a mobile developer? First thing, as a mobile developer, you're probably familiar that user experience is, well, the thing that drives good mobile apps. And AI is really changing the way we're interacting with our phones, with our applications everywhere. So building this into your app can really improve the user experience of your applications, and thus competing other applications that don't implement this in their applications. And it's also really easy, as I'll show you in a bit. We also see the rise of chatbots everywhere, right? Read somewhere that 2017, the year of chatbots. There are quite some sessions here at TechDays on building chatbots. Chatbots have a natural language interface, right? You chat with them, stuff like that. That's also really useful when you can hook up APIs to that really understand the intent of the text that the user is typing. We also see a lot of personal assistants, like the Amazon thing. Google has one now, Apple has one. All the big companies are building their own personal assistants. So if we build our apps to also work with speech recognition, we can really easily hook these applications up to these personal assistants as well. And Astrid showed this picture in the keynote as well. There are sensors everywhere, especially in your mobile phone, and everyone is carrying a mobile phone, or almost everyone. If you look at the amount of pictures taken on the world, my guess would be that 95% of all those pictures are made by mobile phones. So using these pictures and doing something smart with it can really improve user experience, as I will show you in some of the demos. And I think mobile devices are really the interface towards this intelligent cloud that and the intelligent edge that Microsoft is talking about. So having your mobile phone as an entry point towards all the different devices, all the different sensors in this intelligent cloud. And also, especially in mobile, we see a lot of innovation around AI in the mobile space as well, right? Apple with the new iPhone 10, they introduced the A11 chip, which is really an AI processing chip that helps calculate specific AI models. So it really improves all these things like we do in cognitive services, which are APIs hosted in the cloud. Apple's really focusing on chips that could make this processing power available to you on the phone. And we'll look at some demos of that later as well. Next to this chip that Apple introduced with the iPhone 10, they also introduced Core ML, or Core Machine Learning, to make machine learning on the phone really easy with a couple of APIs. So we'll look at that in some demos as well, how we can hook up to this Core ML within our applications. Android is not that far as Apple, I think, at the moment, but they're working on it because Google has TensorFlow, and TensorFlow is the application used for a lot of people for machine learning, the real big machine learning on desktops, and where they do really complex machine learning. But TensorFlow Lite is something they will add to Android to make machine learning available on Android phones as well. And of course we have Microsoft Cognitive Services, the thing that was in the topic of this talk. So what can we use of Cognitive Services to in our apps to add some APIs to our apps? And how I see Cognitive Services is really machine learning as a service. If we do machine learning, we're creating models that can do predictions. And creating these models is really complex. You really have to be a data scientist or someone that's really good in math to create all these kind of models. And what Microsoft did with Cognitive Services is pre-train a lot of models that you can just use and benefit from. And they also made it really easy to have existing models and train them with new data, so you can make really specific models for your own use. If we look at the set of APIs in Cognitive Services, we have 5 big groups of APIs. The first category is vision, and the vision category is all about APIs that have to do with image recognition and stuff like that. So computer vision is an API that you can upload a photo to, and it will tell you about a description of what the image looks like. It adds a couple of tags to it, stuff like that. Really tell me what is in this picture, and computer vision will tell you what's in the picture. We have more things like a face API and an emotion API that can, if you upload a picture of a person, it will tell you the age, the gender, stuff like that about the person on the picture. And the emotion API will actually look at is this guy happy, is he sad, stuff like that. There's also things like the video indexer that are quite cool, not really related to mobile though. The video indexer will make an index of a full video instead of a single image, and it will then tell you which persons are in which frame. So if we have a movie, when is which character actually on screen, you can see those kind of things with the video indexer. We'll not go into the video indexer with any demos because it's not something you would do on a mobile phone. We'll look at some demos from computer vision, emotion API, and face API. Then we have speech. And speech is also quite a useful category on mobile phones, because the first API, speech, is just an API that can translate spoken text, spoken voice into text. So the thing that all your personal assistants are actually doing to process this text. We also have speaker recognition. So if we train a model, train the speaker recognition API with a couple of pre-trained sentences, it can after that check if a voice file is spoken by the same person or if it's spoken by someone else. So you could create login flows with these kind of APIs. Then we have a translator API. It's actually an API that came from Bing, where you can just enter some text in one language and another language will come out. And we have custom speech, where you can actually train a specific model, because, for example, if you want to train a model to work in really special terrain where there's a lot of background noises, you can train the model with these background noises, so it can automatically filter out these noises. So if you want to do speech recognition on a construction site or stuff like that, where you have a lot of drills, etc., you can filter away these noises by training your specific model, compared to the speech model that is really specific or really general speech recognition. Then we have the language category. It starts off with Lewis, and Lewis is an API that can actually tell the intent from a certain text. It's a really useful API when you're building chatbots. You can just give it a text and it will tell you the intent of this specific text. We'll not go into that much. If you're really interested in those kinds of things, you should visit some of the chatbot talks at the conference. They probably go into Lewis. There are some APIs that could be really useful for mobile apps though, like spelling check. If your user has to input stuff, just run spell check on it to improve the user's text. Same goes for text analytics, where you can just check the intent of a text. Is the guy or girl happy in this text, or is he not happy? Stuff like that. It can also analyze what kind of language it is. The translator is in here as well, but that's actually almost the same as the speech one, but the speech one is combining speech to text and then translating it, and the translator in speech is combining those. Then we have some search APIs. They all came from the Bing team in Microsoft. So we have auto-suggest. So if you start typing, it will automatically complete your search. We have image search, so you enter one image and it will find similar images, stuff like that. Same goes for news, video, web. You can just use it to search for similar kind of things. Like like the Bing web engine is actually doing. And the last category is knowledge, and this is a bit harder to use or less known category for most people. So we have the entity linking API, for example, that can you can feed it a certain text, and it will, by learning that text, it will see that certain entities in this text are joined together, right? So if we have a Wikipedia page of our solar system, there would be a sentence of the moon, and the moon is related to Earth, and Earth is a planet. So it will link planet to Earth and stuff like that. So if you would then give me all entities related to Earth, it will also return planet, humans, stuff like that, all things that were related to that entity Earth in that text. Also, a useful thing might be the recommendation API, where you can just feed it several items and items that are linked together. And after that, if you give it one item, it will recommend you a number of other items. Things you see a lot in web shops, etc., where you buy one thing and it will give you more things to buy. So let's look at a couple of use cases before we actually dive into some code. One of the nice things I found was that Uber is actually using Microsoft Cognitive Services in that driver application. So each time a driver of Uber logs in, he has to put his face before the camera of his phone. It will take a picture, and it will actually check if this driver is the same guy as or girl as listed in their backend. Of course, it's quite easy to fake because you can just put a picture of the actual person in front of the camera, and it will still recognize it. But it's a first step that they implemented. If I would implement this myself, I would rather go for the speaker recognition, because that's a lot harder to fake, especially if you ask it to say a really specific sentence that is different every time. You cannot fake it by taping it, for example. Well, speech to text is also something that's really useful. For example, in WhatsApp, we probably all use it sometimes. You can just record a message and then send it as a text. And also a lot of those personal assistants use APIs like this. So if you want to build like a little personal assistant within your application, you could use these APIs. And then the language APIs. Spell checking your user input is really useful. If you have an app where you want to have recommendations or reviews, etc., it's quite nice if you can tell the user, well, thanks for the review, but would you like to improve this review by removing the spelling mistakes? And together with that, if you have this review, you could automatically match the language. So you could store the language together with the text. So if another user logs in and he wants to see reviews for a certain item, you could just show him items of the specific language that user is also using, without the user entering the language he actually wrote the review in. And then, of course, there's also one really famous example that I'll show you now.
It's ready.
Please, God.
What will you say if I told you there is an app on the market?
We're past that part. Just demo it.
Okay. Let's start with a hot dog.
Holy shit!
Yeah, it works! Oh, motherfuck!
Huzzah!
Jin Yang, my beautiful little Asiatic friend. I'm going to buy you the palapa of your life. We will have 12 posts, braided palm leaves. You'll never feel exposed again.
I'm gonna be rich. Fuck you, Guilfoyle. Do pizza.
Let's do pizza.
Yeah.
Okay. Pizza.
Not hot dog?
Wait, what the fuck?
Huh?
That's it? It only does hot dogs?
No, and a not hot dog.
Right, so this example it was on a TV show I really like several months back. So at Xpirit we have these innovation days where we can just code some stuff on a given Friday. So I thought, well, how hard would it be for me to create my own hot dog or not application, right? So I thought, should be doable in 1 or 2 hours, right? So, well, let's use that as a first demo. All the things I show will be on GitHub at my own account, or some examples will be at the Xpirit account. For example, the TechDays app will be there. The rest will be at my own GitHub site. So let's get to Visual Studio and first run this application. Always takes long. Oh, there it is. So this is my hot dog or not application, and I can just take a picture of all of you guys to see if you're a hot dog, because I don't actually have a hot dog somewhere here. So I have this picture, and I'll just ask it to see if this is a hot dog or not. Oh, it's not a hot dog, but I try to make it a bit more complex, so it's actually returning something that it might be. So, well, it says a group of people sitting at a table. Well, I don't see the table, but well, group of people, that's quite correct. Right, so let's give it a actual picture of a hot dog. And boom, it will return that this is actually a hot dog. So how does this work? It's actually quite simple. This is a really basic Xamarin application that has a view model. And this view model has two commands: check image. Yeah. This better? Yeah. Just remove this a bit. What I do in check image, this is a command that is bound to my the button of taking a picture. What we do here is we just use a plugin, just some general Xamarin stuff, to get an actual picture. And if we can't take a picture, we just return. And we store this picture just locally in a variable called file. And we're posting this picture back to our UI. We're also going to get a file stream of this this file, turn it into a byte array, and then send it to my hot dog recognition service. So let's have a look at this hot dog recognition service. It's quite a simple. This is all the code I needed to build my hot dog or not application. So what am I doing here? I'm creating a new HTTP client to actually post our image to. This image has to go to a certain URL, which is api.cognitive.microsoft.com, and then some specific things that we want to analyze an image, and we want to get some categories back. So we want to have categories, text, tags, and a description back. And then we just post this byte array and add that to our content of our request message. We do it like this, and then we just ask, then we send it to our HTTP client and we read the response back. That's all to it. So first I will just show you how to create a service like this in Azure. It's really simple. So we just go AI, cognitive services. If we type cognitive services here, we can choose a lot of different APIs, and doesn't matter which one we're going to create now. We're going to create a computer vision API. Just press create. Whatever API you're creating within cognitive services, they all work almost all work the same way. You just give it a name, TechDays, Vision API. We select the pricing tier. So we have one that's free, which I already created, and we have S1 that costs a bit more, but that can handle a lot more images at the same time. Then we add a resource group, which I already have, and we're ready to go. Right, so is this really expensive? Well, it's not that expensive. Oh, I had to open it. So it was already there. So looking at this, for example, the computer vision API, for the S tier, how many transactions do we want to do in a month? If we want to do 10,000 images, it would only cost us €8.50 a month. Right? That's quite reasonable for such an API like that. And the same goes for all these other APIs. You can just see for yourself what would be the cost if you would implement this yourself. So back to our application. Let me go back to the Azure portal one moment again. So we have our computer vision API right here. And we see that there's an endpoint here, and you have certain access keys. And the access key is just an API key that you can actually use to do these calls. And these are that's actually used here to add to the header of our HTTP client. So we just post this byte array to this API, API with the HTTP client and get the result back. So let's just put a breakpoint here and make another picture. So I'm going to use you for this. Let's see if Gerald is a hot dog.
We're not seeing the screen.
Oh, yeah. So I already just took the picture just like that, and well, we retrieved a string back, which is actually doesn't work. Yeah, pop-up zooming is really hard. So we just get some piece of JSON back that has a lot of things, like it's a person, so that was quite good. Then it has a confidence with that as well. So it's 99% sure it's a person. So that's quite good. Gerald is not a hot dog. And what I do in my application is I'm converting this to my own objects with JSON convert, and converting it to my own object. And this object, if it has a property hot dog, and that's a boolean, I can just make it true or false. So I check if there's any tags containing hot dog or hot or dog, and if that's true, then I say, well, it's a hot dog, otherwise it's not a hot dog. So, well, that's quite simple to build, right? So let's see if we continue. Oh, went to. So see, it's a group of people sitting in chairs. So now it's actually didn't see the table, so it knows what to do. So Hodok or not is something you could build in a couple of hours. So let's just continue with the next demo. I created this. Not on the emulator. Oh, stop. It's hard to take pictures on the emulator, so. So I have this application where I added a number of APIs. So I have the face API here, the emotion API, computer vision, custom vision, speech, and text recognition. So first let's have a look at the face API. So I'm going to use Roy for this one. Smile. Okay, that sounds looks like a reasonable picture. So now it will send this information to cognitive services, and we'll get a result back. And for this example, I just posted the plain JSON, and this is always an awkward moment because it returns a gender, as you can see, like at the bottom right now. Well, that's male. That's a positive. Age 40.1. It's not that bad. I just tested it this afternoon with a colleague. He was 30 and it said he was 58. So it was well, this time was pretty okay. So it'll actually tell him you have to shave. You have half a beard. You do have glasses. It can tell you a lot of things. It tells you things about the hair. What kind of hair do you have? Mostly brown. So that's really, and it will return multiple things of this. So it probably also recognized the guy behind Roy because it has another face ID in here that has the same, well, another face object which is a male of 24.8. So it's probably you. So how do we build this? Yeah. If you go into our demo application here, I will bump up the font as well. It's really simple. It's actually almost the same as our Hodok or not application, because what we did is just do the camera trick again, get the photo stream again, create an HTTP client again, send a picture to it again. Well, all sounds or looks quite similar to our first demo, right? So the only thing that's actually different is that it is a different API, a different URI. So we have to use the face API for this one, and we can tell it to certain request parameters. So what do we want to have from this face API? Do we want to have the age, gender, head pose, smile, facial hair? All those properties we can just see from these properties here. We can, if we're only interested in the age, then we only return the age here, and it will probably be faster with the response. And then we just take the response and return that back to our UI. So really simple. So there were more examples in this application. Let's do the emotion API. Oh, yeah. So I clicked on the emotion API, and I will ask you to smile. So now it's uploading the image. Well, happiness 99%, right? So that's quite good. So let's try again. Now a bit of anger a bit. Oh, well, anger 60%. So, well, how does this code look? It's actually a bit different because the thing I just showed you with the HTTP client, etc., works in any way you're building your application. If you're just building it on the web or a mobile client, or if you're using .NET or any language. But the nice thing about .NET is that there are actually a lot of NuGet packages created by Microsoft, which are in my Android project packages. Let's see if I can zoom this. So there's these Microsoft.Project Oxford NuGet packages, and Project Oxford was the Microsoft research name of cognitive services. So these NuGet packages are still well, using these same names. But we have an emotion, we have a text, vision, API, all these kinds of things we can just get from these NuGet packages. And then it's a bit easier to use. So we don't have to do all the HTTP client stuff that will automatically be done by our NuGet package. So let's look at this emotion API command. It's still doing the same trick with the camera. So in the end, we just get a stream, and what we do is we created a emotion client, and then in the emotion client we can just do recognize async and attach it to stream, and then it will return all the emotions for us in an array. The only thing I do then is if there's any results, I just pick the first one and then create a ranked list, so the highest one is actually used. So we first take the first result, because there could be multiple people with everyone having certain emotions. So we're taking the first person in our results, then get his highest emotion and return that. So we get the emotion key and the actual value, right? So anger 60%. And that's all to it, to creating a emotion API. Since I don't have that much time left, I can just show you the code of some language API, where you can just pass in a text. And I'm actually combining multiple APIs here, also using the NuGet packages again. So I first create a language client, which can see what kind of language my entered text is. That will be stored in a language and language code. And the language code I can then use in my sentiment text analysis API. So I can get the sentiment analysis of my text. And I can enter it in any language, because I first check which language it is, and then tell the sentiment analysis that it's a Dutch text or English text, stuff like that. So I could quickly just show it. Just text. Just type a Dutch text, check text, and it will see that it's hardly readable, but because it's really at the bottom. Language is Dutch, and it's 50% score, so it's not really that good in doing the sentiment analysis. So then I want to show you one last demo, which is actually custom vision. And custom vision is a way where we can have the computer vision API, but then train it with our really specific models. Did any one of you do the treasure hunt today? Because the treasure hunt is actually using these APIs, and we created our own model. So we had these objects. So we had a lamp and a person, etc. And we took a lot of images from that, and we trained the model in recognizing these images. And when you do that, you get an endpoint back. Performance prediction URI. We just get a URI back here that you can use in just the same way as we used for image recognition just before, but then against this model. And the nice thing is that you can, with CoreML on iOS, you can actually download these models and use them offline. So my time is almost up, but what I want to show you is my custom vision model here. I created this model called Xpirit, and I have these Xamarin monkeys here, and I just took a lot of pictures of them at my home. And I trained the model with that, and I'm going to take my iOS application here, so I'm switching phones really quick. Oh. iPhone case. So I'm going to start this application. And what I did is, actually from this URI can go to predictions. Where did it go again? You can actually download a CoreML model. Oh, here, with the export button. You just download it. And you get a ML file. I added that ML file to this application. And when I run the application now, I have to do QuickTime. Oh, it's not the right one. So it's uploading the application now, and it has this this model integrated into the app. So the app does not have to do any HTTP request to do this image recognition. So if I just take a picture of this monkey, it will give results that it's a 99% sure it's a monkey. It's 20% sure it's a partner monkey, because I have two different monkeys here. You can also take a picture of the other monkey. Now it's really sure that's a monkey, and this one says is the Xamarin monkey, so the monkey with the black shirt. So one time do on the partner monkey is not that good with the partner monkey, but it's also it's quite nice that you can do this offline. The model is only 3 megabytes, so it's really easy to add this to your application. I'll be wrapping up, but the only code you need in here is actually creating a loading the model, which is just a file that we just downloaded from Custom Vision, and then create an ML machine learning model, tell it to load the model, and ask it what kind of tags it actually recognizes, and then it will show you a pop-up with this with the tags it recognizes from the model. So it's quite easy to use. Frank Kruger created a nice blog post on how you do this. So I really like that the Custom Vision API is able to export these models. So really, if you want to do this, read up on that blog post, because I'm out of time. So with that, I would like to wrap up, and thank you all for coming.